Greetings! In this video we are going to look at proving trig identities. I've listed some steps here that I think are important to keep in mind. Although nothing works all the time and every problem should be approached based on that problem. But here are some tips to just go by in general. 1. Work on each side of the equal sign but never cross over. So it's okay to simplify one side, and it's okay to simplify the other side, but never should you go back and forth, because in that case you're assuming that they're already equal. Also, it is often, but not always, useful to switch everything in terms of sines and cosines. Our brain thinks about sines and cosines more easily, and so if we switch everything to sines and cosines, we often see connections. Third, you want to try to utilize your common trig identities, the Pythagorean identities, and all of its forms is perhaps the most important, the reciprocal identities, and even and odd properties of sine and cosine. Also, you want to, if you have fractions on each side of the equation, you might want to work to combine them into one fraction, just like when we're solving regular equations. And last, remember the conjugates. We're going to look at some examples where we actually utilize that on the next boards. But conjugates, remember, if you have an expression like a plus b, if you multiply it by its conjugate, it would be a minus b. And remember, when you're multiplying a fraction, one piece by its conjugate, you need to do the same thing to the top or the bottom, depending on which one you chose. Alright, so let's go look at some examples and see it in action. So we want to show this particular identity, that the secant over the secant of x over secant x minus tan x is actually equal to the product of secant x with secant x plus tan x. Alright, so remember, I'm going to work with either side or both sides, but never crossing between the two. I'm going to start with the left-hand side. And this is an example where I see that I might want to multiply by the conjugate. You may think to switch things in terms of sine and cosine, but I look over here and I see that I don't have sines and cosines over there. So I might want to stick with secant and tangent x for a while and see if I can work, if I don't need to switch first to sine and cosine. I might. But because I have this minus sign right here, and I think about the Pythagorean identities, let's list what they are in terms of secant and tangent. Remember that 1 plus tangent squared of x equals secant squared of x. That's the Pythagorean identity in terms of tangent and secant squared. So I want to maybe utilize that. So that makes me feel like multiplying this bottom fraction, or this fraction, and in particular the denominator, by the conjugate of secant x minus tan x. So if I do that, I write secant x minus tan x, and the conjugate is secant x plus tan x. And remember, if I do that to the denominator, I must also do it to the numerator, because that's equivalent to multiplying the original expression by 1. Right? This is really just 1. Alright, let's see what that gives me. Well, the top gives me something that looks exactly like what I'm looking for. So I'm feeling good about this, and I'm hoping that the bottom will reduce to 1. Let's see if that's true. So this should remind you of multiplying binomials, secant x times secant x. So we have to multiply every term in the first set of parentheses to every term in the second. So that gives me secant x tan x, then these inside ones, minus tan x secant x, and then let's do the outside ones. There we have it again, minus secant x tan x, which by the way is the same thing. Oops. This one's a plus secant x tan x. Good thing. And this last one is minus tangent squared x. Alright. Now, since the numerator is looking like what I want it to look like, I'm going to leave that alone for right now. Switch colors. I'm not going to equate this, but I am going to look at just this denominator. Notice that this is the same as this. They're an opposite in sign, so they cancel. So that leaves my denominator right now to secant x squared minus tangent x squared. Now, here's where I think I might use this relationship to simplify my denominator. So I'm going to rewrite secant squared as 1 plus tangent squared. And don't forget, we're going to then subtract off tangent squared. Now look what happens here. My tangent squareds cancel, and I'm left with 1 in the denominator. So what does that make this? Well, let's get rid of this eraser mark so I can write it. This is equal to secant x times secant x plus tan x over 1, which is exactly just this top and what I'm trying to prove. So I finished proving this identity. Fabulous. All right, let's do one more. Let's go to the next board. All right, here I'm in terms of sine and cosine. And before I start switching this, which I may want to switch to sine and cosine, I'm going to first deal with this fraction. I see that 1 minus cosine A, and what I'd rather have is 1 minus cosine squared A. Let's come over here and write the identity that goes with sine and cosine. We have this one burned into our head. This is our favorite Pythagorean identity, but it has another form. We could write sine squared of x as 1 minus cosine squared x. And this is one that's also useful to keep in your head because it allows us to write sine in terms of cosine and vice versa. All right, so just like before, I'm going to multiply the top and the bottom by the conjugate of 1 minus cosine A. And the reason I'm going to do that is because I want to utilize that identity. So this is an example of the conjugate coming into play. So 1 plus cosine A, top and bottom. All right? That's just that first fraction. So then this becomes sine of A times 1 plus cosine A, that's the top, and the bottom becomes 1 minus cosine squared A. This is multiplying, this should remind you of A minus B times A plus B, which gives us a nice identity. All right, now I'm going to extend what this left-hand side should look like. This is minus cotangent of A, and this is minus cotangent of A. Right? I'm just going to extend this all the way down. Now, 1 minus cosine squared A is really sine squared A. Right? So now I have sine A times 1 plus cosine A all over sine squared A. And at this point I am going to rewrite cotangent of A in terms of sine and cosine. This is actually cosine A over sine A, because it's the reciprocal of tangent A, which is sine over cosine. Now I can reduce this fraction over here on the far left, so I can cancel one of those signs, or that sign with one of the signs on the bottom. Now look, I have common denominators. So what this is really equal to is 1 plus cosine A minus cosine A all over sine A. And what that becomes is 1 over sine A, which, lo and behold, 1 over sine A is equal to cosecant A. So we have successfully proven this identity. Go practice!